1.2.8 Unsafe Conditions. Enough unsafe conditions, a physical state that's different from the acceptable, normal, or correct condition found on the job site. It usually results in an incident or accident. Unsafe condition can be anything that reduces the degree of safety normally present. Now, this is a highlight. The following are some examples of unsafe conditions. You can see I've got three of them that are highlighted. Excessive noise, inadequate supports or guards, poor lighting, letting trash accumulate on the job, cluttered work area. That's another example of an unsafe condition. If there's a lot of clutter around, there might be a depression in the floor that you don't see. You step into it, you could twist your ankle, you could fall, you could end up, hurting yourself. 1.2.9, poor housekeeping. This goes along with that clutter that we just spoke of. Housekeeping means keeping your work area clean and free of scraps, clutter, or spills. Let's make that a highlight. It also means being orderly and organized. Store your materials and supplies safely and label them properly. Arranging your tools and equipment to permit safe, efficient work practices and easy cleaning is also important. So here's a container for oily rags. You can see it's got a closed lid that doesn't allow air to get in. That way, when this is sealed, if a fire did start inside this, it would very quickly use up the oxygen and self-extinguish. Remember, here's some good housekeeping rules. Remove from work areas all scrap material and lumber with nails protruding. Clean up spills to prevent falls. Remove all combustible scrap materials. It means you can light it on fire. It's ignitable. It's combustible. Make sure you have containers for the collection of and separation of refuse. Containers for flammable or harmful refuse must have covers. Dispose of waste often. Store all tools and equipment at the proper location and condition when you are finished with them. Keep all aisles and walkways clear of material and tools. You don't want to trip somebody. 1.2.10 Management System Failures. Sometimes the cause of an incident or accident is the failure of a management system. Management systems should be designed to prevent or correct the acts and conditions that can create safety hazards. If the safety management system is not functioning properly, problems are likely to occur. It says a company implementing a good management system will do the following: put safety policies and procedures in writing, distribute written safety policies and procedures to each employee, review safety policies and procedures periodically, enforce all safety policies and procedures fairly and consistently, evaluate supplies, equipment, and services to see whether they are safe, and provide regular periodic safety training for employees. A lot of times when you take a job, there will be an orientation, and during that orientation, they'll give you this kind of paperwork. You should take it home and read it. It lets you know what is acceptable and not acceptable on the job. 1.3.0 Hazard Recognition, Evaluation, and Control. Now we're getting to the point where we're trying to look into the future and determine what could go wrong and taking corrective action before somebody gets hurt. So the process of hazard recognition, evaluation, and control is the foundation of an effective safety program. When hazards are identified and assessed, they can be addressed quickly, reducing the hazard potential. Down here it says it's often referred to as HAZCOM, which is short for Hazard Communication Standard. There's a standard rule in the United States that affects every worker in most industries. That's the HAZCOM, or Hazard Communication Standard. U.S. HAZCOM also aligns with the globally harmonized system of classification and labeling of chemicals. HAZCOM is also known as the right to know. It's the right to know requirement. if you're working with any chemicals on the job site, you have a right to know what harm they can cause you, what first aid measures to take, and what to do in case of overexposure. Requires all U.S. contractors to educate their employees about the hazards, chemicals they are using or may be exposed to on the job site. Employees must be taught how to work safely around these materials. Other countries have similar programs. Many people think that there are very few hazardous chemicals on construction job sites. That's simply not true. In practice, the term hazardous chemical applies to solvents, paint, concrete, and even wood dust, along with more obvious substances such as acids. As an employee, you have the following responsibilities under the hazardous communication policy. Know where the safety data sheets are. That's the SDS. Those are the safety data sheets. Report any hazards you spot on the job site to your supervisor. Know the physical and health hazards of any hazardous materials on your job site, and know the practice, the precautions needed to protect you from these hazards. Know what to do in an emergency. Know the location and content of your employer's written hazard communication program. If you're ever working in an area where they use ammonia for refrigeration, you need to know where the windsock is, know where to find it quickly. They'll have a flag called a windsock, and it shows the direction of the wind. And if there's a release of chemicals, you want to run perpendicular to that flag. You don't want to run into the wind. You don't want to run away from the wind. You want to run across it so that you can get out of the hazard. 1.3.1 Hazard Recognition. The best approach in determining if a situation or equipment is potentially hazardous is to ask these questions. How can this situation or equipment cause me harm? What types of energy sources are present that can cause an incident? What's the magnitude of the energy? What could go wrong to release the energy? How can the energy be eliminated or controlled? Will I be exposed to any hazardous materials? In hazard recognition, you want to take a look at a job step by step before any work is performed and try to be, Murphy's Law, whatever can go wrong will. You want to look at that job and think like Murphy. Try to think of everything that could possibly go wrong on that job during your work and try to mitigate it. Try to take corrective actions before you even start work. Not just you, I mean the whole crew. Any crew working on an assignment, you're going to get together and you're going to do a hazard recognition, a survey. I think they're going to talk about a job hazard survey here in a minute, but you want to do that survey. You want to look at the job and go over it step by step in your mind and try to think of what might go wrong. Can the ladder slip? Should we tie it off? Can the materials fall off of the top of the ladder? Let's tie them with a rope. Anything that can go wrong, let's go ahead and take corrective actions now. Before you can fully answer these questions, you need to know the different types of incidents and accidents that can happen and the energy sources behind them. Some of the different types of events that can cause injuries include the following: falls on the same elevation or falls from elevations, being caught in, on, or between equipment, being struck by falling objects, contact with acids, electricity, heat, cold, radiation, pressurized liquids, gas, or toxic substances, being cut by tools or equipment, exposure to high noise levels, repetitive motion, or excessive vibration. So those are all the things you want to consider when you're doing a hazard recognition survey. Okay. Sometimes as electricians, we think of electricity as the only energy source, but that's not true. There are many of them. The different types of energy sources that can be released include the following: mechanical, pneumatic, that means air, Hydraulic, that means water or oil. Electrical, chemical, thermal, radioactive, gravitational, or stored energy. Okay. Here it is, the job safety analysis. 1.3.2. Performing a job safety analysis, also known as a job hazard analysis, is one approach to hazard recognition. In a job safety analysis, the task at hand is broken down into its individual parts or steps, and then each step is analyzed for its potential hazards. Once a hazard is identified, certain actions or procedures are recommended that will correct that hazard. For example, during a job safety analysis, it's determined that using a chain hoist to install a pump motor in a tight space would be safer than having a worker do it manually. By using the chain hoist, the chance that the worker's hand would get crushed during installation is reduced. So you look at the job, you try to think what might go wrong, and then take corrective actions to correct it before you've even started work. Okay. Risk assessment. Whether an action is considered safe is often a matter of evaluating risk, and this is underlined. Risk is a measure of the probability, consequences, and exposure related to an event. That's what risk is. A measure of the probability, consequences, and exposure to related to an event. So, a safe operation is one in which there is an acceptable level of risk. We understand as construction workers that there is a certain amount of risk that comes with a job. If you're swinging a hammer, you might hit your thumb. It's one of those things that you cannot take away all risk involved. What we want to do is reduce the amount of risk. We want to try to mitigate any risk that is correctable so that we have an acceptable amount of risk on the job. Okay. Reporting injuries, incidents, and near misses. All on-the-job incidents and accidents, no matter how minor, must be reported to your supervisor. Some workers think they'll get in trouble if they report minor injuries, but that's not the case. Small injuries like cuts and scrapes can later become big problems because of infection and other complications. So you always want to report these to your supervisor, no matter how minor you think they are. The safety data sheets, 1.3.5. Safety data sheets are fact sheets prepared by the chemical manufacturer or importer. Each product used on a construction site must have an SDS. An SDS describes the substance along with its hazards, safe handling, first aid, and emergency spill procedures. The Hazardous Communication Standard, or HAZCOM standard, requires new safety data sheets, formerly known as material safety data sheets, to be in a standardized format. The sections of the form include the following, and they've got these, I think, 16 sections. Okay, you have to have the product identification, hazard identification, composition information on the ingredients, first aid measures, the firefighting measures, accidental release measures. But in the first section 1, you have to put the manufacturer contact information and recommended uses and restrictions. If you're ever exposed to a hazardous chemical, don't call the hazardous chemical hotline. Call the manufacturer. They better understand their product better. Well, they understand their product better than the hazardous chemical hotline. Okay. So these are the 16 categories of the safety data sheets, the information that they have to have. Here's an example of one. Here's a safety data sheet. Product name is Weld On. It's cements for PVC plastic pipe. So it's a PVC glue, basically. Okay. And it tells the manufacturer here in section 1. Here's the manufacturer, IPS Corporation, their address, their telephone number. And that's who you'd want to call. Okay. Or emergency, transportation, Chemtel, there's their telephone number. Medical, you'd call this other number. they give you the phone numbers to call the actual company themselves and get information. Then you have the identification. It tells you if it's flammable, if it can be airborne, if it's soluble in water, how it can enter the body. How can it enter the body? Um, let's see here. Where is that part? It talks about uh, you can ingest it, or you can inhale it, or it can be absorbed through the skin, or it can go through openings like your eyes or your nose, your nostrils, what have you. If it's possible carcinogen, or if it's flammable, all that information is in the safety data sheet. The safety data sheet must be kept in the work area and be readily accessible to all workers. You have to make sure that you've got those safety data sheets on the job. The company's safety officer or competent person should review the safety data sheet before the hazardous material is used. I want to talk about what a competent person is as opposed to a qualified person. A person who is capable of identifying existing and predictable hazards in the surroundings or working conditions that are unsanitary, hazardous, or dangerous to employees. And you see that word and, whoops, it went away. And has authorization to take prompt corrective measures to eliminate them. So the way I always say it in class is all 15 of us went to a class and learned about a certain safety procedure. Either it's ladder safety or fall harnesses or chemicals or what have you, or eye protection. We're all qualified, but the company appoints one of us to be a competent person. They say, you have the authority to tell the others they have to wear their safety glasses. You have the authority to shut down the job. If there's a life-threatening situation that you recognize, you can shut down the job. That's the competent person. That word and has authorization to take prompt corrective measures to eliminate those hazards. Okay? Also, an individual capable of identifying existing and predictable hazards in the surroundings and working conditions which are unsanitary, hazardous, or dangerous to employees, and an individual who is authorized to take prompt corrective measures to eliminate these issues. You have to have that and has the authority to take corrective action. That's a competent person. All right. Here's our Section 1 review. The person primarily responsible for your safety is you, yourself. The color commonly used for informational signs is what? Green? Go look it up. I don't know. I think it's green. The SDS for any chemical used at a job site must be available at the job site. We're going to go on to 2.0, elevated work and fall protection. And after we finish this, you should be able to describe common fall hazards and methods to prevent them. Properly set up and climb, descend an extension ladder, demonstrating proper three-point contact. Inspect the following personal protective items to determine if they are safe to use: a fall arrest harness, a lanyard, connecting device. Properly don, fit, and remove the following personal protective equipment: a fall arrest harness. So remember, the fatal four falls are number one. Falls from elevated areas are the leading cause of fatalities in the workplace. Well, that's going to become a highlight. Not sure why it wasn't highlighted already. Falls from elevated heights account for about a third of all deaths in the construction trade. Approximately 85% of the injured workers lose time from work. Approximately 33% require hospitalization. Some never return to the job. Fall arrest consists of equipment such as a body harness, the lanyard, the connection device, lifelines, and safety nets that are intended to protect a worker in case a fall occurs. So the lanyard is the rope that ties to the safety harness and the connection device. A cord rope or similar material used to limit the travel of two connected objects, also a short section of rope or strap, one end of which is attached to a worker's safety harness and the other to a strong anchor point above the work area. Well, why are you not going away? Oh well, I'm just going to go on to the next page. Fall types and hazards. There's a full body harness. Should be inspected every day for damage and wear. Inspect it every day before you use it. Be adjusted to fit the user. Slip your palm between the belt and your body. Make a fist. If you cannot pull it out, it's adjusted properly. Be taken out of service if it has been involved in a fall. A safety harness, the way it was explained to me, is meant to save one life one time. So you have a brand new safety harness. You take it out of the package, you put it on, you tie off your lanyard, and you slip and fall, and the lanyard and the safety harness stop you from falling to your death. They saved your life. When they come and rescue you, when they pull you back up on the landing, and you go back down to the break room, they're going to take that safety harness and that lanyard, and they're going to destroy them. They're going to get rid of them. They've done their job. It's less than $100. It's meant to save one life, one time. And once you've fallen one time, you've broken some of the stitching. The harness has taken an impact, and it cannot be trusted to save you a second time. So it has to be destroyed and taken out of service. I say destroyed because they're not just going to throw it in a dumpster. Someone's going to reach in there and pull it out. And they're going to take it and use it. So it has to be destroyed. Falls are classified into two groups, falls from an elevation and falls from the same level. Falls from an elevation can happen during work from scaffolds, work platforms, decking, concrete forms, ladders, stairs, and work gear excavations. Falls from an elevation often result in death unless the fall is arrested. Falls on the same level are usually caused by tripping or slipping. Sharp edges and pointed objects, such as exposed concrete reinforcing bars, could cut and otherwise harm workers. So you can slip and fall on the same level and still get hurt. A fall from an elevation is worse, of course. 2.1.1 Walking and Working Surfaces. Slips, trips, and falls on walking and working surfaces cause 15% of all incidental deaths in the construction industry. Some incidents occur due to environmental conditions such as snow, ice, or wet surfaces. Others happen because of poor housekeeping and careless behavior, such as leaving tools, materials, and equipment out and unattended. You can avoid slips, trips, and falls by being aware of your surroundings and following the rules on your site. Remember these general walking and working surface guidelines to avoid incidents. Keep all walking and working areas clean and dry. Keep all walking and working surfaces clear of clutter and debris. Run cables, extension cords, and hoses overhead or through crossover plates so that they will not become a tripping hazard. Do not run on scaffolds, work platforms, decking, roofs, or other elevated work surfaces. 2.1.2 Unprotected sides, wall openings, and floor holes. A lot of times falls occur because people are on a floor and they have a false sense of security and they're not wearing a fall harness, a fall arrest system. And they get too close to the edge of the platform or to the landing, the level, and they end up tripping and falling off of the third or fourth or fifth or 20th floor of a building, and they fall to their death. Any opening in a wall or a floor is a safety hazard. There are two types of protection for these openings. They can be guarded, enclosed, fenced, covered, or otherwise protected by barriers, rails, covers, or platforms to prevent dangerous contact. So you can cover them with a sheet of not less than 3/4 inch plywood nailed down to the form so that it can't be moved. And then you write on it with spray paint, caution, hole. Or two, they can be covered. There you go, there's the cover. Cover any hole in the floor when possible. Hole covers must be clearly marked. When it's not practical to cover the hole, use barricades. If the bottom edge of a wall opening is less than 39 inches above the floor and would allow someone to fall 6 feet or more, place guards around the opening. Okay, so these are some of the things that we'll have for protection. Several different types of guards are commonly used. Railings, warning barricades. Red means danger. No one may enter an area with a red warning barricade. A red barricade is used when there's danger from falling objects or when a load is suspended over an area. So if you see a red barricade, it means there's flying material overhead. Don't go in there. Yellow means caution. You may enter the area with a yellow barricade, but be sure you know what the hazard is and be careful. Yellow and purple together means radiation warning. They call it magenta, yellow and magenta. No one may pass a yellow and purple barricade without authorization, training, and the appropriate personal protective equipment. These barricades are often used when piping welds are being x-rayed. Protective barricades give both a visual warning and protection from injury. Blinking lights are placed on barricades so they can be seen at night. Hole covers are used to cover open holes in the floor or in the ground. So here's a barricade. Here's tape. That's the least efficient, I believe. Here's a fence. Here's those Bob's barricades. And then here they've actually covered it with a piece of wood. Fall arrest. That's your harness. The whole fall arrest system consists of the harness, the lanyard, and the anchor point. That's the fall arrest system. The key to preventing serious injury or death should a fall occur is the personal fall arrest system. A complete personal fall arrest system consists of anchor points, a body harness, and connecting device. That should be highlighted. I wonder why some of these highlights are not highlighted. Anchor points are related to the structure, and the type and availability of anchor points help determine what other equipment should be chosen. The body harness comprises the system of belts, rings, and hooks worn by the worker. Connecting the devices and lanyards are used to maintain attachment between the anchor point and the personal fall arrest system and include lanyards and various pieces of hardware. Each separate piece of a fall arrest system has to be rated for 5,000 pounds. Your anchor point has to be rated for 5,000 pounds. So don't get one of these carabiner clips and think that's going to take the place of an anchor point. I'm just going to clip that around a pipe. Don't clip around a piece of rigid conduit or EMT. Those are not rated for 5,000 pounds. If you weigh 200 pounds and you fall 6 feet, at the end of that 6 feet, I forget what they said, you're something like 1,800 pounds of force being put on that lanyard and that anchor point. So make sure that you're using only approved anchoring devices. Here's a nice picture here. There's a personal fall arrest system. Here's your anchor point. That's an I-beam, and they've got it a ring, an O-ring, or anchorage connector. It's not going anywhere. Here's your connecting device. This is a deceleration device. It allows you to walk slowly or to climb around, but it retracts like a seatbelt. But if you were to slip and fall, it only allows you to fall about 2 feet, and then it catches and it doesn't allow you to fall any further. So those are very nice. Those are super to have. So here he is. He's got his body harness with his D-ring between his shoulder blades. That's where you want it. You want your D-ring between your shoulder blades, just like this one over here. Okay. All right. This training alone does not provide any level of certification in the use of fall arrest or fall restraint equipment. Trainees should not assume that the knowledge gained in this module is sufficient to certify them to use fall arrest equipment in the field. There you go. Anchor points. There are both permanent anchor points and temporary reusable anchor points. Anchor points must be rated at or equal to 5,000 pounds, breaking or tensile strength, or twice the intended load. So these are anchor points. I don't like to see someone take their lanyard and go around an I-beam. I know this is probably not an I-beam. I can't really see it in the picture. If this is an I-beam and you put your lanyard around it and double it back on itself like that, if you fall, this I-beam, if this were an I-beam, would be sharp enough to cut through it. It would cut the webbing and you'd end up falling to your death. This, however, I don't see it being an I-beam. I think it's a square beam. And so this guy's okay to do what he's doing. Okay, tie back lanyard. All right. Fall arrest anchor point will be located directly above the back D-ring in order to minimize any swing zone hazards as well as the free fall distance. When you uh, when you anchor off, you want to try to put it above your shoulders. You want it as high as possible. Lift up over your head and attach your line above your head. You don't want to attach at your knees because if you've got a 6-foot lanyard and you're 6 feet tall and you put it at your knees, well, you're going to fall 9 feet before that thing catches. And at 9 feet, your acceleration, I don't know the math. I'm not going to get into what it's going to turn into in newtons per square meter. You're taking a risk. Make sure that you anchor as high above your head as you can reach, and that way you're going to shorten the distance that you might fall if you do slip. Okay? And they're explaining all that. I'm not going to go into it. I'm just going to go on. Harnesses. Full body harnesses like the one shown in figure 10 are available in sizes that are based on the height and weight of the user. The back D-ring is the only one used to connect the harness to the anchor point for primary fall arrest purposes unless you're climbing a ladder. So you want to make sure that that D-ring is between your shoulder blades on your back. Okay. Let's see, and they call it a 4-point body harness. 4 points, because you got 2 around your legs, you got 2 over your shoulders, and that gives you those 4 points of contact. Installing the harness. A body harness must fit correctly to ensure that it will provide proper protection. Do not place additional holes or openings in the harness components under any circumstances. No field modifications to a body harness or lanyard should be attempted. Installation, maintenance, and inspection instructions are provided for every harness, and it's the responsibility of the worker to read and understand the details regarding his or her personal equipment. Don't ever alter any of your safety equipment. You're not allowed to drill holes in your hard hat. They've had people in the past do that because the hard hat was too hot. So they drilled holes in it, made it like Swiss cheese to let the air in. That degrades the strength of the hard hat, don't you think? Yeah. So something falls on your head and your hard hat splits open like an eggshell. And so does your head. No, don't alter your hard hat. I've worked at places before where they said you weren't allowed to even put stickers on your hard hat. If you had a little Daffy Duck sticker or whatever, or, your someone you knew gave you a little flower sticker or something for good luck, and you put it on your hard hat, they tell you got to take that off. Take that off your hard hat. Can't have it. They said that the glue from the sticker could degrade the plastic over time underneath the sticker, so they weren't allowing it. All right, let's see here. Installing a harness. This is something that you should do in class with your instructor. They should show you how to do this, how to don. There are two words in the English language. They are archaic. They're from the mid 1800s. But those words are don and doff, D-O-N and D-O-F-F. To don is to put something on. They say, don we now our gay apparel. Follow all along, okay? Don. Don your safety equipment. Don your hard hat. Or they use it a lot in respirators. They teach you how to don and doff the respirator. Because if you put a respirator on correctly and you're in a hazardous environment, when you get out of that hazardous environment, you don't want to take the mask off over your head and shake all of that contaminant down into your lungs. So you have to lean forward and you take it off and you let it fall in gravity. And if it's a dusty environment, they might even have showers for you that you get into the shower and you shower off away from yourself. You don't open your mouth, you don't sing a lullaby while you're in there. You make sure you hose off and get all of that toxic dust or whatever it is. They'll teach you that. Don't think you're going to go on a job site. They're just going to hand you a respirator and go, there's asbestos in that room. We want you to go in there and install a disconnect. They're not going to do that. Don't worry about it. But you will be taught. If you need to use a respirator, they will teach you the proper ways of using that respirator. But those are the two words, don and doff. And here it says how to don a harness. Hold the harness by the back D-ring. Shake the harness to allow all the straps to fall into place. If chest, leg, and or waist straps are buckled, release the straps. Slip the straps over your shoulders so the D-ring is located in the middle of the back between the shoulder blades. That's where it goes. That's where you want it. I need to do something to make my cursor a little bit more visible on these videos. Pull leg straps between the legs and connect to the opposite end. Repeat with a second leg strap. If belted harness, connect waist strap after the leg straps. Connect the chest strap in position in the mid-chest area, tighten to keep the shoulder straps taut. And then after all the straps have been buckled, tighten all the buckles so that the harness fits snug, but allows full range of movement. The back, here are some notes here. The back D-ring location is vital to proper fall arrest, and this is underlined, it's highlighted. Position this ring between the shoulder blades. If it's too low, it will tend to cause the body to hang in a more horizontal position. Let's see here. I'm not going to read all these. They have a tendency to. Okay, we're going to talk about suspension trauma. A suspension trauma strap is recommended as part of the personal fall arrest gear. The suspension trauma strap is stored in a pouch connected to the harness within each easy reach. This is done by either one end of the strap being permanently sewn to the harness, one end of the strap attaches to the harness with the carabiner, or by choking the pouch around a harness strap or hip D-ring. The strap can then be quickly removed and used without any possibility of the user dropping it. Once connected, the strap allows the worker to stand up in the harness. This is what they're talking about. This is, well, I shouldn't say it's relatively new. I've been out of the business for 20 years, so it's not really relatively new, but these are suspension trauma straps. If you're ever in a safety harness and you encounter a fall and the safety harness saves your life, the safety harness can also take your life. The way these straps are across your legs, they cut off your blood supply to your legs. And they'll say, well, you can just pretend like you're pedaling a bicycle. But they've taken some athletes and had them hang from a harness and try to do that bicycle motion. and within 5 minutes they said that they were absolutely exhausted. You can't keep it up. And what happens is it restricts the blood flow so that the blood pools in your lower extremities. Your heart still pumps, your blood still circulates, um, but you find that over time it pools in your legs. And if you're there for more than 15 minutes, your blood is becoming toxic. They've had people hanging for more than a half hour and were perfectly alert and talking, and everything was seemingly okay. They got them down and they took off the harness, and the person went into toxic shock and died because this blood is now poisonous. It has a lot of contaminants in it. It's because your body is still trying to um, uh, secrete the waste material into the bloodstream, not knowing that the blood is not circulating. And it collects a high concentration of these poisons. On low concentrations, it goes to the liver, and the liver filters it out, and everything's fine. High concentrations, the liver can't handle it, and it circulates through your blood, and it ends up killing you. So they put these straps in here on the sides. I hope you can see my cursor. These straps. And if you find yourself hanging, you pull down these straps and it makes a nice little harness for you, a little step stool that you can put your feet in. And now you're able to straighten your legs, and it takes the pressure off of these main arteries here in your legs. Uh, what is that? Is that the carotid artery? No, the carotid is in the neck. It's the one down, in your groin. The you you want to make sure that that blood can flow. So by standing up in those suspension trauma straps, it allows the blood to circulate, and it doesn't accumulate the poisons. So that when they do get you down, you're going to be fine. Okay. Anytime anyone is hanging from a harness, though, when you do get them down, you don't want them to take the harness off. Don't let them take the harness off. If it's you, don't take the harness off. Loosen the straps around your legs one notch. Sit elevated so that you're sitting upright against a wall or a tree with your legs outstretched straight, and you can work them back and forth. If they call an ambulance, tell the ambulance driver that this person needs to be sitting up on the stretcher when you take them to the hospital. What happens is if there is an accumulation of poison in the blood in the legs because of pooling, if you lay them down, it goes to your heart and it goes to your brain and it kills you. If you keep sitting up, it slows that effect and they can save you. They can take you to the hospital and they know how to treat that. But the ambulance driver doesn't know anything about it. They don't get it in their training. Of all the training they get, it might be mentioned once, but they're not thinking about it. You need to point it out to them. Hey, this is a suspension trauma. They need to ride to the hospital in a seated position. Okay? Please make sure that you understand what I just spoke about. You'll see that the time I spent explaining this one concept means that it's very important. Okay? Uh, there's one of those carabiners. You can't use that. You can't use that. Has to be rated for 5,000 pounds, and I'm sure this one's not. Okay. It's important to note that not all hardware will qualify as a competent component of a personal fall arrest system. Some hardware is to be used only for attaching tools and equipment to workers or to the structure. All right. Double locking snap hooks. Yeah, they're usually curved and have an opening to allow connection to a line that can be securely closed. It usually takes two actions to open these. They're usually not consistent in appearance as a carabiner and come in somewhat different shapes. When used as part of the personal fall arrest system, the security closure should be automatic. Snap hooks are designed to connect to D-rings primarily, not to each other. And it takes two actions to open this. You can't just open it. Here's a piece on the back that has to be pushed forward. And when you push this one forward, this moves out of the way and allows the one in the front to move back. But if you don't push the one forward in the back, this one in the front will not move. It's a safety. It's a double action hook. Okay, double locking snap hook. It's for protection.